Namaste everyone. Hope all of you are well. Actually, till yet, in the all previous 8 lectures of this equilibrium chapter, whatever you have studied, the thing should be noted in your notebook. This is the 9th lecture of equilibrium chapter. In the previous video, I have explained about the pH values. Today especially I will talk about the types of acid, and after understanding the types of acid, then I will tell you about the ionization constant of different type of acids and bases. So first of all, I think that all of you are aware about these types of acid, because you may know the types of salt also: acidic salt, basic salt, neutral salt. So because of this ionization constant, we have to understand about these acids and base. So let's start. Types of acid, if I talk about, according to Arrhenius equation, I have told you types of acids. Can you tell me how many types of acids? I hope all of you know about it. If I talk about the types of acid, then I have informed you there are 2 types of acid according to the nature of strength. One is strong acid and another is weak acid. Now you can ask me, sir, what is this strong acid? You can ask me. In a simple way, if I just want to tell you that strong acid means acid which dissociates their hydrogen ion easily in aqueous solution is called strong acid. Means if you are putting a strong acid into the aqueous solution, then it will not take too much time to dissociate it. Rapidly it will dissociate. So that type of acids are called strong acid. I can give you the examples of strong acids like H2SO4, sulfuric acid, hydrochloric acid, nitric acid, and another is phosphoric acid. There are many, but I have given you some examples. These acids has a property that they can dissociate their hydrogen ion into aqueous solution easily. That's why they are called strong acids. Now what's about the weak acid? Weak acid will dissociate their hydrogen ion with difficulties. Generally all the organic acids are weak acid. If I talk about acetic acid, formic acid, this is formic acid which is especially found in the ants, acetic acid which is found in the vinegar. You know very well all the organic acids are weak acid. Carbonic acid, that is fizzy drinks. In the fizzy drinks we found carbonic acid. So these all the acids are weak acids. So according to the strength, as I have told you that there are 2 types of acid: strong acid and weak acid. Here we have to learn only this type of acid, but if I talk about according to the concentration, so then also there are 2 types of acid. One is concentrated acid, and another is diluted acids. Monobasic, dibasic. So if I talk about them according to what, if I divide anything, then you can ask me a question, sir, according to strength, according to concentration, according to what you have divided this acid. So if I talk about, so according to strength, here the strong acid and weak acid. According to strength, concentrated. Also concentrated means you will see the solute amount is maximum and the solvent amount is minimum, is called concentrated acids. And when the solvent amount is maximum, especially if I talk about the solvent like aqueous water, so that if we mix more and more water into the concentrated acid, then it will convert into the diluted acid. So these are the things we do not have to understand right now. Right now our main topic is to understand about these ionizations, how these strong acids and weak acids give you the knowledge about the ionization constant. Just suppose that if I talk about these weak acids, first ionization of weak acid and after that ionization of strong acids. Okay, so ionization of weak acids. Okay, if I take any acids, HX is the acid, okay, and I put into the aqueous solution. You know very well what is going to become hydronium ion, right? It's going to become why it will become hydronium ion? Because acids will liberate H plus ion, right? H plus ion in the aqueous solution, and it will mix with H2O and it will become H3O plus. And if I talk about this remaining part, then X will be. It is an equilibrium reaction. You can see this ionization of weak acid I am showing you. First of all, let me make you understand. At the starting means initial. If I talk about the concentration, what is the concentration of this? So you can ask me, sir, what will the initial concentration? It's very easy to give you. See, initially, at initial, the concentration of this acid was C, just suppose, okay, and initially these were 0 because at starting only this acid was there. Now, the concentration after the T times, the hydronium ion concentration has changed into alpha, okay, has changed into alpha, okay. So what will be the, after T times, what will be the concentration of HX? Can you tell me? It will be this ionization extend, means if I talk about this alpha has been extended of ionization change. Extended of ionization change. So C minus alpha, whatever will be the concentration, that minus alpha we can write here. So initially it was C and now C alpha it became. So C alpha, so C minus, if I have a C alpha, this will become C minus C alpha after time T. Initial, and you can say it's fine, okay, C minus C alpha. So if I talk about this ionization constant, after the time T is equal to 0, and after the time T, HX has been ionized into the two ions. Using these notations, we can derive the equilibrium constant. Now we have to just derive the equilibrium constant for dissociation equilibrium. So what will be the weak acid dissociation constant? Weak acids dissociation constant. If this is alpha, just suppose I am giving you a little bit hint also. Just C alpha after the concentration. So this became C minus C alpha. So now if I talk about the dissociation constant of weak acid, dissociation constant of weak acid. So you know very well what is dissociation constant. Constant is the concentration of product. What are the concentration of product? C alpha and C alpha, and the concentration of reactant is C minus C alpha. Is it right? Yes or no? Yes, it is right. Now you can tell me that if we are just removing this concentration, then what it becomes? C square alpha square upon C common, C minus C alpha, C into 1 minus alpha, right? 1 minus alpha. So C cancel and I see C alpha square upon 1 minus alpha. So this is the rate constant or ionization constant of weak acid. You have seen that if you divide, means Ka is here called dissociation or ionization constant of acid HX, because here we have taken an acid HX. So here HX, dissociation constant of weak acid, Kw, is the concentration of product upon concentration of reactant. We have got a value C alpha square upon 1 minus alpha, right? Now, as Ka is called the dissociation or ionization constant of acid HX, it can be represented at any other form. Now, at a given temperature T, K is measured of the strength of the acid. Means if the temperature is given, then you can easily see that the rate constant is of weak acid or strong acid. If the strong acid, Ka is dimensionless quantity, with the understanding that the standard state concentration of all species is 1 molarity. In your NCERT in table 7.6, the values of ionization constant is represented in your table 7.6. You can go. So the pH scale of hydrogen ion in concentration been useful, that besides pKw it has been extended to other species and quantities. So if you want to write this concentrations pH value, then P concentration of weak acid or strong acid is minus log Ke, means P concentration of minus log Ke. So this is the pH of the rate constant or dissociation constant of acids. Knowing the ionization constant Ka of an acid, it can be initial concentration C. It is possible to calculate the equilibrium concentration of all the species and also the degree of ionization of an acid and the pH of the solution. Say, remember dear students, there are some steps by which you can calculate this, how ionization constant of strong and weak acid can be calculated. The main things which we should understand is initial concentration of the acid and the final concentration of the acid. As you get a knowledge of initial concentration, the product will be 0, and at the final concentration, the product value and the reactant value will be initial concentration minus product values final concentration. So you will get here the ionization constants of weak acids, strong acids, both the values it can be easily calculated. You can get a pH values also. There are some numericals in your textbook that here I hope that in the previous video I have solved also these things. Here the question is given here that the ionization constant of hydrogen fluoride is 3.2 into 10 to the power minus 4. 3.2 into 10 to the power minus 4, it's given here. Calculate the degree of dissociation of hydrogen fluoride in its 0.02 molarity solution. Calculate the concentration of all the species present in hydronium ion and fluoride ion and HF in the solution and its pH. So there are many things we have to calculate. First of all, we have to write the reactions. Here, the same thing is there, no need to worry. Here HF is there and we mix into H2O. The reaction is H3O plus and F minus. See, you can compare this reaction. Is it equal? Yes or no? Yes. Now you know very well. Here rate constant value is given. The Ka value is 3.2 into 10 to the power minus 4. The value of Ka is 3.2 into 10 to the power minus 4. The rate constant value is given into the question, as you can see. Right? Now, the second equation is waters, means two equations are there. If you mix water into water, then again here the equilibrium constant H3O plus and OH minus. Here also the rate constant value is given and that value is 1 into 10 to the power minus 14. So that you know very well. Right? 1.0 into 10 to the power minus 14. This thing we have calculated already in the previous videos. I hope now in this equation HF plus H2O, H3O plus and F minus. Now you can ask me, sir, what is the initial concentration and what is the final concentration? Right? Here in the question it's given that the initial concentration is 0.02 molarity 0.02 milliamp, right? And here this will be 0. And at the final step, you know very well, we are just assuming that it has been changed from initial concentration, that 0.2 alpha, 0.02 alpha. What is 0.02 alpha? 0.02 alpha. So what will be here? It will be minus. From here this has been deducted. So minus 0.02 alpha. Okay, now the final change, equilibrium concentration final change, what we have to do, whatever the values has been given, that is, means here the values, initial concentration was 0.02 minus 0.02 alpha, right? And here 0.02 alpha and 0.02 alpha. Got it? Now we have to calculate this value. The rate constant already the values is given, that is 3.2 into 10 to the power minus 4 is equal to concentrations of product. What is the concentration of product? That is 0.02 into 0.02 alpha square upon 0.02 minus 0.02 alpha. Right? Can we write like this? Yes or no? Because the concentration value is given here, you can see. Yes? Now you can ask me, sir, here should we write 2 times or not? First of all, these things must be represented. That's 0.02. Here we are calculating of H3O plus or both. Right? So here first of all, if we put here 0.02 into 0.02 alpha into alpha, right? That is alpha square. And here we are taking common 0.02, 1 minus alpha. So this 0.2, 0.2 cancel, 0.02 alpha square upon 1 minus alpha is equal to 3.2 into 10 to the power minus 4. 3.2 into 10 to the power minus 4. Right? Now what we do? We do cross multiplication. Right? So as we do cross multiplication, you will get an equation. And that time you will get the values of this alpha. So let us first of all do the cross multiplication. Okay. Here you can see that the equation will be 3.2 into 10 to the power minus 4 into 1 minus alpha is equal to 0.02 alpha square. Is it right? Because here you can see at the last step, yes, what we have to do? We have to do cross multiplication. So as you obtain this equation, what you will get? The equation will be obtained as 3.2 into 10 to the power minus 4 minus 3.2 into 10 to the power minus 4 alpha, that is 0.02 alpha square. Means here we are going to create a quadratic equation. What we are going to create? Here we are going to create a quadratic equation. Okay, just suppose, my dear student, no need to worry. Just no need to, okay? Can we write here 3.2 into 10 to the power minus 4 and this 0.02 here, can we write it down? into 1 minus alpha is equal to alpha square. Can you write this? Yes or no? Yes, we can write. Why not? So this is 32 upon 10 and this is 2 upon 100, right? Into 10 to the power minus 4 into 1 minus alpha is equal to alpha square. 0, 0 cancel. 16 2s are 32. So here 160 upon 1, 2, 3, 4. 0, 0 cancel. 1.6 into 10 to the power minus 2, right, is equal to this much alpha. 1 minus alpha is equal to alpha square, right? So 1.6 into 10 to the power minus 2 minus 1.6 into 10 to the power minus 2 alpha is equal to alpha square, or we can write a equation alpha square minus 1.6 into 10 to the power minus 2 alpha plus 1.6 into 10 to the power minus 2 is equal to 0. So this has been created in the form of quadratic equation, right? Quadratic equation, and you know very well how to calculate the value of alpha. If it is looking very hard to you, no need to worry. You can write like here that minus a plus b into 10 to the means, if you want to calculate here the value of x is equal to minus b plus minus under root b square minus 4ac upon 2. So if you want to change this quadratic equation, then you can write here alpha square minus 1.6 upon 100 alpha plus 1.6 upon 100 is equal to 0. So take the LCM 100 alpha square minus 1.6 alpha plus 1.6 is equal to 0. Or you can write this equation like this: 100 alpha square minus 1.6 alpha plus 1.6 is equal to 0, right? Here 100 into 1.6, that is 10.6. Here we have to break this. Hundred alpha square minus 1.6 alpha plus 1.6 is equal to 0. So after 0.12 you will get, as you will calculate this value, x is equal to minus b plus minus under root b square minus 4ac. So here the value of x is equal to, or you can write here the value of alpha. Instead of x here in the equation we have put alpha, right? So we can write here the value of alpha is plus minus 0.12. Plus minus 0.12. What we can write the value of alpha? Plus minus 0.1, right? So here when we put the value of alpha minus 0.12, then the value will not be suitable, right? So the value, the negative root is not accepted, and hence alpha means here alpha is not equal to minus 0.12, so that's why alpha is equal to plus 0.1, right? So as we get the value of alpha 0.12, this means that the degree of ionization is 0.12 and the equilibrium concentration of other species like hydrogen fluoride, fluoride minus and hydronium ion, you can just put the value and you can calculate. Means 0.12 into 0.2. Here you can see that if you want to calculate the concentration degree dissociations of hydronium ion, 0.02 alpha means 0.02 into 0.12. If you want to calculate the fluoride ion, then again 0.02 into 0.12. If you want to calculate here HF, then minus 0.02 into 0.12. So the values will be of hydrogen fluoride C into 1 minus alpha, that is equal to 0.02 into 1 minus 0.012, that is 17.6 into 10 to the power minus 3. So here hydrogen fluoride value is 17.6 into 10 to the power minus 3 molarity, and pH value will be 2.62. So I hope that this is the nice way to understand this concentration. You can solve these questions very easily. There are more examples given in your NCERT textbook, so you can go through that, and I hope that you can calculate. So that was of weak acid, but now we will calculate about the weak bases. So let's start for the weak bases. Similarly, as I have discussed about the types of acids, if I talk about the types of base, right? Types of bases. So there are, according to the strength, there are two types of bases. First one is strong base and another one is weak base. As in the types of acid, as we have studied about that the strong acid and weak acid, that the strong acid, the acid which dissociates or which donates or dissociates the hydrogen ion very easily in aqueous solution called strong acid. Similarly, if I talk about the strong base, then you can say the base which dissociate hydroxide ion easily in aqueous solution, rapidly in aqueous solution, very fastly in aqueous solution is called strong base, and which dissociate hydroxide ion with difficulty is weak base. Strong acid, I can say you that NaOH, examples of strong acid NaOH, KOH, right? NaOH, KOH. And if I talk about the examples of weak acid like ammonia, NH3, here nitrogen will not dissociate OH minus ion, right? So if any, or you can say that as I have told you about the weak bases also, many more, there are some, like if you are taking calcium hydroxide, weak base, you are taking some other hydroxides which are very weak base, which dissociate hydroxide ion very difficulty. As we have discussed types of bases, strong base, weak base. In the acid, we have discussed about the ionization of weak acid. Here we discussed about the ionization of weak bases. Ionization of weak bases. Just suppose that here this is a base, and base, weak base is that when you put into the aqueous solution, it will be termed as, can you tell me what it will be termed as? I hope you know very well. It will be dissociated as M plus and OH minus ion. But remember, this OH minus ion, they will dissociate it with very difficulty. In a weak base, the partial ionization of here any hydroxide, it will be converted into M plus and OH minus. The case is similar that of the acid dissociation equilibrium. So here the base ionization constant, similarly if you want to calculate the base ionization constant, Just remember here, no need to give here like a solution directly. If I just write the equation, then you can see here that NOH equilibrium M plus and OH minus, right? So if you want to calculate here the base ionization constant, the concentration of product and the concentrations of reactant, right? Is it right or not? Can we write this way? The ionization constant of weak bases. Similarly, if you want to calculate, it will be again C alpha square upon 1 minus alpha as it was in the acid. Similarly, if you want to just suppose that, if you want to calculate this only, that NOH gives M plus and OH minus. Initially, the concentration is C 0 0. After then this alpha, this became C alpha. So as C alpha, and this will be C minus C alpha. So if you want to calculate the ionization constant of weak bases, so here Kb will be the C alpha into C alpha upon C minus C alpha. So C square alpha square upon C into 1 minus alpha. C square cancels. C alpha square upon 1 minus alpha. So here the value of Kb and Ka both are equal. If I talk about the base also and if I talk about the acid also, the values of this ionization constant will be equal. So if we talk about some of the specific bases like dimethylamine, trimethylamine, ammonia, quinine, pyridine, aniline, urea, these all the values are given already in your textbook. Many organic compounds like amines are weak bases. Remember, as I have said you that all the organic acids are weak acids. Similarly, here all the organic bases are also weak, but in the specific amines, organic amines are weak bases. Remember this, all the organic amines are weak bases. So here, as some of the examples and the values of ionization constant is already given in your NCERT textbook, so you can notice it from that also, and we are going to solve one question here. Okay, one thing I would like to tell you, that if I talk about the ammonia, what will happen to the ammonia? NH3 plus H2O. It will be just like NH4 plus and OH minus, ammonium ion, right? Here, if you want to calculate this ionization constant for the weak bases, then here one question is there also. And similarly, as we have written in the acid, the pH value of this. So here pKb, pH of minus log Kb. This value also you have to remember. Just take a screenshot of this board. After that we'll solve a numerical as it is already solved in your textbook, but there also I would like to solve. So here the pH of 0.004 molarity hydrazine solution. Hydrazine solution is 9.7. Calculate the ionization constant of base. P means Kb and pKb. You have to calculate here both the values. So you know hydrazine solution, that is NH2. So, okay, let's solve. Here the equation is hydrazine so this is your equation. In this question that some values are given. From the pH we can calculate the hydrogen ion concentration. Knowing the hydrogen ion concentration and the ionic product of water, we can calculate the concentration of hydroxyl ion also. And here, as we know, H plus is anti-log minus pH, right? So here the log values, if you know, then it's very easy. H plus concentration is minus anti-log pH. H plus concentration is minus anti-log. Can you write this? Yes or no? Yes, definitely we can write. Now the values we have to write. Minus anti-log is given. Anti-log value is given. Anti-log minus 9.7. What is the value? In the question it is given minus 9.7. That is equal to 1.6 into 10 raised to 1.67 into 10 raised to minus 10. As I have given you in the acid also that it was 1 into 10 to the power 1.0 into 10 to the power minus 14. So OH value here, the OH minus will be the given concentration value upon H plus ion, right? So here if I talk about OH minus ion concentrations of weak acid, so Kw value upon KH, OH minus ion concentration is equal to Kw upon H plus. So that is 1.0 into 10 to the power minus 40 upon the value of H is, what is the value of H? That is 1.67 into 10 to the power minus 10, right? Yes or no? Yeah, definitely. So here the value of H plus is 1.6 into 10 to the power minus 10. So what will be the value? Can you tell me? 10 upon 16 into 10 to the power minus 4. So as you divide 10 by 16, the value will be 5.98 into 10 to the power minus 5. 5.98 into 10 to the power minus 5. So this is the value of OH minus ion, and the concentration of the corresponding hydrazonium ion is also the same as the hydroxyl ion. So the concentration of both of the hydroxyl ion, these ions will be very small in the concentration of the dissociation base, that can be taken to 0.004 amp, 0.004, as it is given also in the question, that is 0.004 amp, right? Now the second thing in the question is you have to calculate about the values of Kb. It's very easy, you know very well the concentration. Kb is equal to here 5.98 into 10 to the power minus 5 upon 0.004. As you divide 5.98 into 10 to the power minus 5 upon 0.004, you will get 8.96 into 10 to the power minus 7. 8.96 into 10 to the power minus 7. And you have right now only written that Pkb is equal to minus log Kb, right? So here minus log 8.96 into 10 to the power minus 7. So it will be minus log 8.96 and minus 7 log 10. That is, the value will be 7, and here whatever will be the value of 8.96 you can calculate, and the final value will be 6.04. 6.04. Okay, so by this way it's very easy, just as we have calculated about the ionization of acid and ionization of base. So weak acids and weak base we have calculated the values. Now we have to establish the relationship between the Ka and Kb. This thing is very easy, as you can see also that how we have done it, and the types of acids, polyacids, polybasic, monobasic, dibasic, tribasic, these are all the things we will study in the next video. In this video we have just learned about the ionization constant of weak acids and weak bases, how to solve the numericals related to that, and hope all of you have understand. In the next video we will go through that, and we will also discuss about the dibasic, polybasic acids and dibasic, polybasic bases, factors affecting the strength of acid and bases, common ion effect in the ionization, acid and bases, and then finally we'll discuss about the buffer solution. And I hope that one or two video, maximum one or two videos are left in this chapter. The things which you are learning, it must be written in your notebook, because as you learn the things and you forget it, if you do not do practice and practice, you will not be able to understand. That's all for today. Thank you very much. Hope all of you have understood. If you have not, like and subscribe my channel, and don't forget to like and subscribe my channel. That's all for today. Thank you very much.